Welcome to the Arcus demonstration video. In this short screencast, I will show you how to use the Arcus Thunderbird add-on to generate a key pair, to encrypt emails, and to decrypt emails. For this demonstration, I have set up an Ubuntu environment and I have already installed a test account in Thunderbird. And just FYI, this is the add-on page on addons.thunderbird.net. So in case you wish to read more about the add-on, you can go to the extension, to the add-on pages, and read the README here. So let's jump right into Thunderbird email, and I will show you first how to install the add-on. In Thunderbird, you go via the menu, add-ons and themes. Then you go for the search and enter Arcus. You get two results. This one is the old one, which was based on a Go implementation, and the new one is based on Rust. So we will take this one. We say add to Thunderbird. And now there's a list of permissions that have to be reviewed, and then you can say add. I've explained the list of permissions in the README, so in case you need more information, just read there. So there are no surprises, just to give you the information. It's for small things you need a lot of permissions. That's sadly so. So you will have to accept the whole list, but there's no surprises, so don't worry. I clicked add and now Arcus was added, so it's installed in Thunderbird. We can close this tab and we can go into the add-ons manager again and to extensions, and now manage your extensions. It's the installed extension in your Thunderbird and they're enabled in Arcus. And now you see here version 091 is the one I published today, and this one is the installed one. In case you want to have a look at the source code, I've published it on GitHub. There you will also see some explanation for the permissions again. I will close the add-on tab now, and now we are back into the main window of Thunderbird. On the top right, you now see a button which is called Arcus, and it's new. You can click on it and then the tab will open. This is a tab that is coming with the add-on, and it just gives you some short information and gives you some tools you can use to encrypt, decrypt, and to generate a new key. One of the most important things here is especially the manage your secret key form, because later on we will see how to automatically decrypt emails inside your Thunderbird. But to automatically decrypt received emails, you have to store your secret key inside Thunderbird, and that you can do here. The key is never stored somewhere else. It's really just stored inside your Thunderbird installation, so it never leaves your device. Now, I guess you don't have a key pair yet, and so we will use the form generate new key here. It has a button generate, and now let's click on it. What happened was that a new key pair was generated. You should store it somewhere safe. You can use the download button below. Self-explanatory. And what do we see here? It's a key pair. It's a pair because there are two keys. It's the public key and the secret key. The implementation is based on the RAGE implementation of the H encryption concept, and therefore you have this format H secret key and the H1 public key, and you will recognize this maybe if you have used H in the past. It's the same. It's literally the same implementation, just ported to WebAssembly. So we have a new key generated, and for this demonstration, what we want to do is now copy the secret key, copy it, paste it into the manage your secret key form, say save, And now the secret key is stored inside your Thunderbird, and you also receive the public key again. We can check it. This one is the same as this one, so there are no problems. Now that this secret key is stored inside your Thunderbird installation, emails that you receive will be decrypted if the secret, if the encrypted text is encrypted with your public key. We will see this now. It's better to see it. So let's just write an email. To write a message in plain text, you hold Shift and then click Write. We're now in plain text compose window. And the background why I do this, because Arcus at the moment only works with plain text emails. HTML emails are a bit complicated, and they have a lot of code snippets, so to say. It's better if you use plain text emails to write encrypted emails to someone else and to receive as well. So we are now in the plain compose window. We write an email to ourselves again and say this text will be encrypted. Then we click on the Encrypt with Arcus button. And now a pop-up appears. And in this pop-up, you see a list of recipients. You get the message that not all recipients have an H key stored in Thunderbird. And a third block which lets you add an additional recipient. In this case, since we have a secret key already stored in Thunderbird, Arcus uses the public key of our secret key to automatically encrypt messages to ourselves as well, so that later on, if you wish to decrypt text that you send to someone else, it's also encrypted for your key, so you can decrypt it. In this case, let's just try out. I will add Arcus test. Just think about it like we would write to someone else, and we say add to list. Now the public key is added, and so we have two recipients. They use the same key in this case, but you get the idea. And then we say encrypt, and as soon as I click on encrypt, the text in the compose window will be encrypted for these two keys. Now I close the pop-up. What we are left with is the previous compose window with a recipient, with a subject, but our text, our plain text message is replaced with a ciphertext. And now we are ready to send it. Let's try it out. Sending message. And now remember that we encrypted the email for ourselves as well. So we have the secret key stored in Thunderbird. And what will now happen is that if we open the email, Arcus will automatically decrypt the text content because we can decrypt it with our secret key. And that's what happens here. If you look closely, if I open this email, the encrypted file block that we sent is still visible. After some milliseconds, the block is replaced with a decrypted block and the original text is shown. The last thing I want to demonstrate is how can you store public keys from other people in your Thunderbird so you don't have to edit manually every time. And I will show it again with our own key. This is the corresponding public key. So let's say we go into the address book. Let's say Arcus test is someone else. And we wrote an email to someone else before. So I would like to store the public key from Arcus test in Thunderbird so I don't have to enter it every time I write an email to this contact. We just use a custom property that is provided with Thunderbird, and we use the custom for property and enter the H key and say save. And now you can see that for the contact Arcus test, the custom for attribute is the public H key stored in the address book. So now that you have stored the public key of this contact in the custom for attribute in the address book, what you will see is a difference in writing an email. We will write a third email now. Just use Shift and Write again to switch to plain text. And we use the email address from the contact, Arcus test in this case, say third email, and say this is the third text for testing. And as soon as you click on encrypt with Arcus, again, the pop-up appears, but now the list of missing contact keys that we saw previously has disappeared because Arcus could map every recipient in the to field to a stored public key in Thunderbird. And now you see that it's the same table as we had before, where we added an additional recipient by entering the key here. But now Arcus did it for us, and we have two recipients. In this case, they use the same key, but remember, we are simulating something here. So this would be a different key, and you would encrypt the message for two recipients, for two public keys. And if you click on encrypt, the same happens again. We have the to field, we have the subject, but now our body text is encrypted with H. And we send it, and we receive it. And as soon as we open it, or you have seen it below, the third text for testing is automatically decrypted. That's it. You've seen how to install the add-on. You have seen how to generate a key pair. We have sent an encrypted email. We have stored a public key from a contact in the address book. And we have decrypted received emails. Thank you for watching.